When you usually see binomials, what do you kind of think of? What do you think of usually?
Like when you've got the two terms and they're squared or to
Okay.
the power of 3.
Right, so you've got some sort of expansion or brackets, right? Expansions or brackets or something like that. Binomial expansions, or we looked at the binomial theorem as well. But we can actually generalize this idea of the binomial theorem and apply it to probability. In a specific case though, what case is that? Well, that case is when we have two possible outcomes. So we have independent trials, we can run like an experiment, but there's only two possible outcomes. Well, what's the kind of situation where you don't have two possible outcomes?
Heads or tails?
Right, like flip a coin, right?
Yeah.
Is that going to be heads or tails? That's two possible outcomes. We could also kind of generalize some situations to have only two possible outcomes. For example, for a test, even though I can get marks from 0 to 100, how could I have two possible outcomes out of a test? Even though there's so many different marks I could get, is there a way I could reduce the outcome of a test?
Pass or fail?
Yeah, good. Yeah, pass or fail. Okay. I can have a pass or a fail.
It's like below 50 or above.
Yeah, right. So if I got below 50, that's fail. If I get above 50 or above, that's a pass. And one thing you might have is like hit or miss. If you're like firing an arrow, something like that, right? You can have a hit or miss situation. Cool. Okay, so that's the binomial. Well, that's when we can apply this idea of binomial probability. To start though, I just want to look at a quick example. Okay, an example you might have seen before, but I want to shed some new light on it. So let's look at this situation. Okay, so this situation here, right? If I'm flipping a coin 3 times, and I want to look at the outcomes, what's the usual method that you do to solve this kind of problem? Usually, how do we usually approach it?
Like times the number of times the number of outcomes per time it's flipped by the number of times it's flipped to get the total number.
Sure, right. We can use our probability rules there. But visually, what's even before we attack the actual outcomes? What's a visual way of representing this kind of situation?
Oh, there's like a probability tree.
Good, yeah, a probability tree, okay. So yeah, we can draw a probability tree to answer this question. And you've answered tons of questions like this. I want you to see the situation in some new light though. Okay, I'll show you what I mean. Don't have to draw the probability tree, I'll just draw it out for you really quickly. Right. So you know, after heads, you know, we can get heads or tails, Those are all the outcomes that we have. And remember, binomial probability, we're looking at only two possible outcomes here, right? Okay, so this is the situation I've got. I'm flipping a coin 3 times, right? And that's why I've got these 3 separate stages here. Okay. I can also write out all these outcomes here. H, H, T, H, T, H, H.
Are you going to use that pyramid thing to do it?
Ooh,
What's it called?
are we going to use the pyramid thing?
It looks like the pyramid you've got there, because you use the numbers above it.
1, 2, 3, 4, 5, 6, 7. Cool. I'm not going to use the pyramid thing, but I'm going to think about sort of arrangements. Okay. Do you remember those?
Oh yeah, terms and columns.
Okay, so what was
Oh yeah.
What was the permutation?
It's got to be in the same order. And
So for permutations, we say order matters.
Yeah, permutation, wasn't Miss Hemming sort of P equals pick in a certain order or something?
Oh yeah.
and a
combination
combination doesn't matter.
Yeah, it doesn't matter. Okay. Now, the way that they generally try and think of it is like a combination is like a committee. It doesn't matter who's on the committee. If all 3 of you are in a committee, even if you're picked in different orders, you're still on the committee. So order doesn't matter there. Permutations is where order matters. So think about positions in a race. That's how first, second, third is different to third, second, first, right? As in, if you swap the people who want around. I want to think about the same thing here. Instead of just counting the outcomes, I could do that really easily. Like finding the probability that you flip. So this should be exactly. We're not looking for, or at least. Right? So here, 1 head. I can see that there's obviously 1, 2, 3 outcomes there that meet that criteria, and then you can divide it by the total number of outcomes. That would just be 3 over 8. I want to look at a different way though. Okay, let's think about our arrangements here. Let's think about our arrangements. I want to think about kind of these positions almost of these outcomes here. When I'm looking for the probability that I flip one head, does it matter? Does the order matter where that one head occurs? If I'm looking for the probability that I flip exactly one head, does it matter where that head occurs? No. So the order doesn't matter, does it? No. It doesn't matter where that head occurs as long as it occurs. Does that make sense? No. So, which arrangement would that be?
A combination.
It'd be a combination, right? This is what I'm looking for. I don't care where that head occurs. I just know that out of these 3 tosses, I'm looking for one head. It doesn't matter where it happens. Okay. How could I write that using my notation? Well, the number of ways, this is for A by the way, the number of ways would just be 3C1. Right? I've got 3 tosses and I want one head. Okay. But what else do I need? Well, I want to think, if I'm trying to use this idea of kind of positions now, I want to think, what are the probabilities of each of these individual outcomes? You look at all of these here, right? Remember, I'm only looking for one head, right? So, the number of ways I can get head, what's the probability of flipping one head? That's just half, right? So flipping heads, that would just be a half. So if I'm only flipping one head, what are my other 2 outcomes going to be? They're going to be flipping tails, right? But not just one tail, I'm flipping 2 tails, good, right? So what's the probability of flipping 2 tails? That would just be, well, since flipping a coin, it'd just be half times half, wouldn't it? Yeah. Right? Or half squared. Okay? So now I'll put this all together. I'm not trying to think about it in terms of just looking at the outcomes that I want divided by the total number of outcomes. I'm trying to use this idea of arrangements to help me for much larger problems. So I've got the number of ways that this outcome occurred, the probability of what I'm looking for, like the success, right? If we think about these 2 outcomes that can occur, heads or tails. And then the probability of it not reaching, not meaning what I'm looking for, 2 tails. I can put them all together, and to answer this question, I could just write this as 3C1 multiplied by half, multiplied by half squared. You can calculate that for me now. Just double check that's right.
3 over 8.
Okay, 3 over 8. And that checks out, right? Because, right, the usual way we do this is, okay, how many total outcomes are there? There's 8. How many times does exactly 3 heads occur? Well, 3 times, so that would just be 3 over 8. We can do this for any kind of situation now. If we start to generalize this idea. For 2 heads, what do you think I would do? How many ways could I get?
3C2.
Right, 3C2. Right. 3C2. Okay. And we can also just verify that manually because we've got it here. I'm looking for when 2 heads occur, so there's that one, and that one. And it's really clear here why we're using combination, right? It doesn't matter what order these heads occur, right? All I'm looking for are the situations where I have 2 heads, right? If I swap these 2 around, right, that's still the same thing in this case, isn't it? Right? So that's why it's really clear why I'm using combinations here. What else do I have? Well, I've got the probability that I flip 2 heads. So that's the number of ways. Flipping 2 heads, how do I do that? That's just
half times a half.
Yeah, half squared, and then flipping tails. Yeah. What would that be? So I'm putting them all together now. So I've got the probability is actually equal to 3C2 times half squared times half. Check that for me.
I got 3 over 8.
3 over 8, and that checks out. Same idea, right? We can verify that really easily. Last one, just do it really quickly. I'm not going to write out and break it down each time, but what would be the expression I want to write to represent this situation? If I'm looking for all heads now.
3C3.
Yeah, 3C3 times half to the
3.
What about the tails?
Well, you're not flipping any, so
I'm not flipping any. Yeah. Good. So what would that be to the power?
To the power of 0.
Yeah, right. Right, so you can start to see a pattern emerging, right? These powers are changing depending on what I'm looking for, right? So keep that in the back of your mind. So I'm flipping 3 heads, that's half times half times half, and I'll have 0 tails, and that should just be 1 over 8, okay? I want to look at one more situation before I generalize, and we'll look at some more tricky ones, okay?